Hey everybody, welcome to topic number 6, quantitative data and its graphs. So I introduced the qualitative data before and their graphs. So in this topic, I want to take a look at the quantitative data and its graphs. So the first objective here is something called the stem and leaf plot, stem and leaf plot graphs or stem plots. So basically, the stem and leaf graph or the stem plot comes from the field of exploratory data analysis. It's a good choice when the data sets are small. So to create the stem and leaf graph, you probably seen this before. You've probably done this before in high school. Divide each observation of data into a stem and the leaf. And the leaf consists of a final significant digit. For example, 42 has a stem of 4 and the leaf of 2. So that means the leaf, the leaf part is always a last significant digit. So for stem and leaf plots, you basically have a stem and you're gonna have leaves. Okay. So the leaves is always the last significant digits of your data. So why don't we just look around the data and start from the smallest. So the single data value here is only 2 digits. So we'll have 1 digit on the stem and of course always single digit on the leaf. So let's do the smallest one. I have 25. So 2 here, 5 here. So this 2 means all the data value that are in the 20s. So that's 5, 7. Oh, and there's a 0 here. Sorry about that. 20 is the smallest one. So that's 0, 5, 7. I don't think I need a comma for it. 0, 5, 7. All right, let's do the stem 30s. So all these numbers are in the 30s. So 32. So look around 36, 34. All right, the 40s. Stem 4, last value is 40. And let's see. Oh, there's a 38. I left out 43, 44, 46, 48, 49. So single digits, right? Final digits, okay, goes on the leaf. All right. Oh, there's a 7 too. 7, 47, 0, 3, 4, 6, 7, 8, 9. So the reader know this is 40, 43, 44. Okay. All right, 50s. I believe 51 is the smallest. 53, 5, and 7. There you go. That's how we create a stem and leaf plot. Okay, just one display for quantitative type of data. Our other type of quantitative type of graph is called the line graph. Okay. So the graph below shows the x-axis consists of the data and the y-axis consists of frequency points. So here's the data, okay? The x-axis consists of number of times teenager is being reminded doing chores. Okay, so there are 40 mothers, so total frequency here is gonna be 40 mothers. So a typical line graph, okay, no reminder, frequency is 2. So the y-axis here are the number of consisting of frequencies. Okay. So line graph, very simple. A lot of people have seen line graph before. Okay. It's a popular display for quantitative data. Now, a lot of people probably never seen this before. This is not a bar graph. These are something called a histogram. So from the previous topic, those frequency distribution can eventually lead to our frequency distribute can lead to histogram. Okay, the most popular display. So in topic number 5, when I show you where we divide our data into class, right? I think the example we had with the plasma TV, we had about 6 classes or something like that. okay? So that distribution translate into this particular type of graph called the histogram, okay? So histogram is a bar graph with frequency distribution of quantitative data. The x-axis consists of class boundaries. So these x-axis consists of class boundaries. That's why I show you that word called a class boundary. The y-axis can either be labeled as frequency or relative frequency. Okay, so some of those words that we learned from topic number 5 is actually used to this. It's actually used for the histograms. So right now, this is a number of books bought by 50 part-time students at a college. Okay, so we can see the x-axis is using boundaries. All right, we got 1, 2, 3, 4, 5, 6 bars. That means there are 6 classes. Okay, so construct the frequency distribution. So we got 6 classes. So I'm gonna do it right here. We got 6 classes, right? And I'm gonna figure out its frequency. So the question is, okay, what are the 6 class? Okay, so remember so this number must be the lower class limit minus 0.5. So if I do it in reverse, this is add 0.5 back. So that's 1. This, it must be the upper, this boundary must come from the upper class limit plus 0.5. Let me think. Let me make sure. The lower class limit minus, right? So if I go reverse, normally it's 1. So normally the lower class limit minus 0.5, the upper class plus 0.5. So if I minus here, that would just be 1. So this 1 to 1, right? The next class. So this is buying 1 book. So this must be buying 2 book. So I guess we're not going from 1 book to 2 books. So second bar, second class, this number must be come from the lower class limits. So that one must be come from minus 0.5. So if I add it back, it's plus. And this one will be minus. So that would, either way, that would be 2. Okay, so I bet my class is 1, 2, 3, 4, 5, all the way up to 6. All right, frequency, this is about 11. This is about 10, 16. This is about 6, 5. And the last class is about 2. There you go. All right, find the upper class limits of the second class. So that would just be 2. Since these are boundaries. All right, find the class width for this histogram. So class width, we can either subtract 2 consecutive lower class limits, or we can subtract the boundary. Either way, if you take any 2 consecutive boundary or class, lower class limit, subtract them, the class width is 1 at a time. All right. Number 4, find the percentage of student that bought more than 2.5. So this is looking for percent. Okay. So let's see what's the total number of books bought first. This is 50 students. So hopefully when I add them up, it should be 50. So that's 11. Oops. Plus 10, plus 16, plus 6, plus 5, plus 2. All right, so that's 50 books. Or 50 students. But a percent student that bought 2.5 more books. 2.5 more books is referring to this bar to the right. This bar to the right. All these are more than 2.5 books. Okay, so that's 16, right? So that's so the 16 is to the right side of 2.5 boundaries. So that's this, and this one together. So that's 50. So that's 11 plus 10. Excuse me. Right, which is 21. So there are 21 that's actually not included. That included what I want. What I want is from 3 books and more, 3, 4, 5, 6. So I can take 50 minus 21 and say there are 29 books or 29 students, excuse me, 29 students bought 2.5 more books. So percent is part over the whole times 100. So 29 students bought 2.5 more books divided by total 50 students times 100. So that's about 58%. Okay. So 11 students bought 1 book, 10 students bought 2 books, 16 students bought 3 books. So so if you add up 16, 6, 5, and 2, that will still give you 29. Or we can say the total is 50. What I don't want is buying 1 and 2 books. We're going to subtract that off and still come up with the 59. All right, so just a little bit of just want you to see the histograms, and I will show you how to graph this histogram in the graphing calculator here in a little bit. But remember, we do have a project coming up. So in the project, okay, the x-axis, okay, are the boundaries, okay. So I just want to make sure you kind of see how this graph, what the axis, x and y axis is supposed to be. All right, this thing called a normal distribution means the graph has a bell curve shape. Okay, a graph that has a bell curve shape. So all these examples here I have are histograms. Okay, so the bell curve shape is referring to a graph that is symmetric. Okay, a normally distributed is symmetric. So that means, here's the question. That means it means symmetric means bell curve shape. Okay, it looks something like this picture. What that picture means is the center. Okay, the mean is actually in the center. Okay, the mean of the distribution is somewhere lying in the middle of the entire bell curve shape. Okay, so this is a lot more about this coming up in other topic. We actually talk a lot about this bell curve shape in this class. Another type of distribution is called the uniform distribution, where pretty much all the frequency, okay, occur about the same. Okay, almost every bar is about the same height. It's called a uniform distribution. Okay, a distribution, this bell curve shape thing is something called a skew to the right. If it's skewed to the right, that means the tail is on the right. So that means majority of the data lies towards the left side. Okay, called the right tail. Skew right is right-tailed. That's how you actually look at it. Skew right is right-tailed, where majority of data is concentrated on the left side of the graph. Okay. Skew left is called the left-tailed. Okay, left tail means majority of the data is concentrated on the right-hand side. That's why it's skewed to the left. Okay, so wherever the tail is, that's how you know whether it's skew right or skew left. Okay, but the one that we are most interested in is the bell curve distribution. Okay, we talk a lot. We will talk a lot about this. Okay, in other topics. All right, let me show you how to grab a histogram in a graphing calculator. So, like I mentioned before in other topic, normally when you are given a distribution, okay, the class is already given to you. Okay, it's not an actual data. This is actually called the grouped data. Normally, a distribution is given as like a grouped data. So what I mean is, okay, this is, for example, this is actually a score range of the personality questionnaire. All right, so class 16, the score 16 to 19, it happens, 4 people score 16 to 19. But exactly what each person scored is actually unknown. We don't know whether all 4 of them score 16, all 4 of them score 19, or 3 score 17. We don't know none of that information. Okay. So when that happens, in this type of grouped data, what we will do is assume everybody, okay, is assume the midpoint is what everybody's score is. So the first thing that you need to do is find the midpoint of each class. So if I take 16 plus 19, then divided by 2, the midpoint of my first class is 17.5. So that means I am assuming there are 4 people scored 17.5. Okay. Now by looking at the class width is 4. Right? 2 consecutive lower class limits subtract together, that give me the width. So that means I just need to plus 4 every time. Then I can actually get to, find all the class midpoint pretty quick. Okay, so these are the class midpoint. And these class midpoint will be on will actually be entered under L1. Okay, so for group data, okay, I have the instructions for you to for the group data and for the raw data. They enter a little bit differently. So enter midpoint on the L1, enter midpoint on the L2. So for your calculator, got to have a graphing calculator for this. For your calculator, what you want to do is go to stat. Okay. Try number 4, clear list. So that means if somebody ever put anything on there in your calculator, okay, we can actually go ahead and clear it. So clear list, second L1, okay, and it's done. So nothing's on the L1. So if I go to stat, choose number 1, edit, there's nothing on the L1. All right, nothing should be in here at all. So if there is something in here on the L1, L2, whatever, go up, highlight the list, press clear, press enter. Do not press delete. If you press delete, you're literally gonna delete this right here. Okay, you're literally gonna delete the word L2, list 2. All right, so if you're missing stuff, let's say if you're missing L2 or missing L3, one of the easiest way is to clear the memory. Okay, clear the entire calculator's memory. Let me show you how to do that. So the word memory, press second and the plus sign, and go to number 7, reset, and choose number 2. We'll go back to default, and then reset. Okay, so everything is resetted. So now, when you come back to stats, you should have nothing in there. Okay, so under L1, I'm gonna type in the midpoint. Press a number, press enter. 21.5, press enter. All right, just press enter after every number. Okay. All right, press the right arrow key. That will put you on the top of the L2, lined up with 17.5. So let's enter our frequency. 4, enter. 10, enter. 4, enter. 9, enter. 9, enter. So make sure that these lines are exactly parallel, okay? You don't want to have one extra class with no number on it. It won't graph it for you. Okay, now press second in the stat plot. Second stat plot is right above y equal. Choose plot 1. Okay. Press, see right now the blinking is on the on, so I'm press enter. So now the word on is blinking. So that's how I know I just turn my plot 1 on. If you press enter again, you turn it off, basically. Or you gotta go turn it off. Okay, I'm gonna turn my plot 1 on, and I'm gonna select the histogram. Histogram is this third picture. So I'm gonna come down and then press enter. Highlight that, press enter. Okay. X list is on the L1. Your frequency is on the L2. So that's alpha number 2, or shouldn't be alpha. It's actually L second 2, because my 2 is blue color. So I'm gonna press second and number 2. They tell me the frequency is on the L2, the X list, which is the midpoint, is on the L1. All right. So now press the word zoom. Press number 9. Choose zoom stat. Number 9 is called zoom stat. They actually graph it for you. Okay. Now we're gonna press window, and then we're gonna fix some of these. Okay. X minimum, X maximum are the lower class and upper class limits. Okay. X minimum is the lower class limit of the first class. So the lower class limit of the first class is 16. Then the upper class of the last class is 35. X scale representing class width. So we said class width was 4. Press enter. Okay. Y minimum, Y minimum is referring to the frequency. The smallest frequency is 4. We can go lower than that. So let's start with 0. Larger than the highest frequency. So the highest frequency is 10. So we can say a little bit bigger than that. We can say 15. How about that? Okay. Y scale all stays as 1. Not 1. Press graph, it will fix it for me. There you go. 1, 2, 3, 4, 5. 5 classes. Okay, that's how we draw the histogram. Press the word trace, it tell you what these numbers are. So these numbers, so where the cursor is located is actually at the midpoint of the class. Okay, you actually point at the midpoint of the class. All right, that's how we graph a histogram from the graphing calculator. Okay, so if you're not quite sure, that's all the steps is right here on the handouts, and you can rewatch that part of the graphing of the lecture video. Frequency polygon is another type of quantitative graph. It looks a lot like line graph, but it's not quite the same. A frequency polygon is a visual display of frequency of each class of quantitative data that use straight lines to connect the points plotted above the midpoints. That's the key part right here. Okay, so these dots are actually on the top. It's actually located at the midpoint. Okay, so frequency polygon basically comes from a histogram. Well, let me go back. Comes from like a histogram. Okay, so if you put a point at the middle of all the bars, okay, and then erase all the bars, then that's where these points are located. All these points are located at the top of each bar, okay? And then if you erase all the bars and then connect the points, okay, to the boundary, then there you have it. Okay, it's called the frequency polygon. So this example shows, this is an example of a frequency polygon. It uses lower bound, lower class bound on the x-axis, and it also uses upper bounds. Okay. And here are our frequencies, okay, of each class. Okay, just want to show you some of the display. All right, so here I have a line graph. Okay, I want you to, this is a multiple choice. Use a line graph to find the lowest combined ACT scores for the 5 years shown. So 5-year ACT score, this is actually a line graph. Okay. Frequency polygon is very unique because you actually need to start off from 0. See this frequency 5 right here? That's right here under the, it's right here at 54.5. So it's go from 0 to 54.5. Okay. And at the very end, it go back down to what? Go back down to the x-axis. It has to draw it that way. But line graph, you don't connect back to the x-axis. Okay. Question number 2. Use the histogram to answer some of these questions. Okay. It'll be easier for you to write them down before you enter them. Find the upper class limit of the third class. So the third class is 1, 2. This is a third class. So find the upper class limit of the third class. So remember, this number this boundary of that third class come from the upper class limit plus 0.5. So to go backwards, you will need to subtract the 0.5 to get your upper class limit of third class. Find the class width for me, find the number of students that took this exam. So that means add them all up. These number on the top means the number of students to the exam for each class. So add them all up, that will be the answer for number 4. And then find the percentage of students that score higher than 85.5. 85.5 and higher is everything to the right of 85.5, and find the percentage students score higher than 85.5. And the last two are actually uses on multiple choice. So let's go back here, make sure I don't say it wrong. All right. Use a straight line to connect points plotted above the midpoint. So my fault. These are not class boundaries. I don't think these are midpoints, right? I think those are midpoints. Let me double check. Yeah. Yeah, these are midpoints. Sorry about that. These are midpoints. Okay. The x-axis representing the midpoint. Sorry about that. Okay, not the boundary. These numbers are midpoints. Because I was wondering why there's no 44, 54.5. 44.5 got to be the midpoint of the first excuse me. 54.5 got to be the midpoint of the first class. So sorry about that. These are midpoints, okay, for the frequency polygon. The histogram uses class boundaries, okay, as x-axis. But frequency polygon uses class midpoints as x-axis. Okay, sorry about that. So that answers 3 and 4. Okay, so just real quick, showing you some of the popular display of quantitative data in their graphs. Okay, thank you for watching.